I don't have currently questions from the audience, so I would suggest we go directly to our panel discussion. So I would like to invite now to introduce my panel guests. Araceli Venegas-Gomez, you already met, I already introduced. She's founder and CEO of QURECA, Quantum Resources and Careers. Horst Weiss is a Vice President of Global Digital Services at BASF. And my other guests are Samantha Edmondson. She's a head of talent at Universal Quantum, where she's now working to expand and develop a team of physicists, hardware engineers, software developers, and operation staff to work together to build a quantum computer with million qubits, as they announce. So welcome, Samantha. Nice to have you here. My next guest is Oliver Bodensiek. He's from the Quantum Technology Training and Education. He's a lead of Quantum Technology Training and Education at National Metrology Institute in Germany. And he's adjunct professor at the TU Technical University in Braunschweig, also here in Germany. Welcome, Oliver. Nice to have you here. My next guest and my last guest on this panel is Sebastian Hassinger. He's a business development. He's doing business development at Amazon Quantum at Amazon Web Services, and Sebastian has been involved in the commercialization of early stage technologies since the beginning of his career, and he has joined AWS Quantum to 2021, and now he leads the worldwide business development and market strategy to the public sector. So it's a pleasure to have you all here. And I would like to start with a question, as we already now partially discussed during our first presentation. There is a lack of engineers, not just in quantum, but pretty much across the whole IT sector and all engineering professions. So where do you see specific aspects that are unique to the field of quantum computing and require special attention with regards to the talent pool and workforce? Who would like to start? Maybe Samantha, you can start.
Yeah, absolutely. Obviously working in quantum, we are then looking for talent that, as you've identified, is already in scarce supply. There is a shortage of engineers. There's certainly a few aspects that are unique to the field of quantum in that. The first is, very much a plus in that I've certainly found working and recruiting for this area, it's, a really distinguishing factor and an ability to attract engineers to this field that they will be working on cutting edge, world-changing technology. It's also the fact that these people have to be very comfortable working with physicists and, very cold temperatures, very unique circumstances that they may not have encountered before. So that can either be a plus or a negative in either case.
Thank you. Any other views on that question?
Yeah, I would just add to what Samantha was saying. I think that in quantum, in the field of quantum, it is an emerging field, as Dr. Weiss is pointing out in the last talk, and therefore everyone is going to be cross-training in some sense, right? You're either coming from more of a scientific background and having to learn more about the commercial aspects of product development, software development, or hardware development, or you're coming more from that kind of a background and you're having to learn more the scientific research aspects. It's very unique in that there is this sort of one foot in the fundamental science world and one foot in the commercialization and technology development world. And I think that poses a unique set of challenges.
Anyone has other thoughts about this question? What is unique for the shortage of quantum computing, for the bottleneck in quantum computing workforce on the market?
I think the capabilities you need are very, very demanding. So very often you meet people who have a fair knowledge in electronics, but they have a complete lack in understanding quantum mechanics. You need quantum mechanics understanding, but where do you learn quantum mechanics? Mainly in physics. When you're a theoretical physicist, it's very unlikely that you have a lot of experience in how to build an amplifier. I mean, there are many people like this, but this is what I try to say when we make these courses at the university. It really deserves a special profile, a big profile, that combines capabilities that so far were not necessary for doing a certain job. It's even worse for the programming, I would say. I don't know if you ever looked into a system where you develop. I mean, they do the best to shield you from the complexity. But underneath and very close underneath, you need to understand how the present implementation in terms of quantum circuits is actually functioning in order to write anything that starts to work. If you want to go into the optimization arena, it's difficult to find people. And then to close this on the algorithmic side, I mean, when you look about the foundation of Shor's algorithm, maybe you can accept it, but if you want to understand it, I would say you need a fair amount of understanding in number theory. And so in principle, you would need a person who knows everything about mathematics, quantum computing, and laser technology if you're in photonics, cold atoms when you start with the Rydberg business, ion trap construction. So this is, it's fantastic, it's cool. You manipulate quantum objects, but you don't find people who have experience in everything. So totally impossible. So it's now emerging. All these competencies are emerging, and we need to structure this in sort of several courses at the university in order to construct there a proper workforce. At the moment, I must say, we are hiring people who are really experts for algorithmic developments. But those people are not necessarily the one that would work as domain experts in, say, quantum chemistry, for example. It is still separated.
So do you think that a solution, or at least one of the solutions, could be, at least currently, to lower down at least this high demands for the workforce, and maybe try to upskill people at the place, at the working place already? Samantha, what are your thoughts about this as a hiring manager?
I think, as you say, you recognise the impossibility in hiring somebody that has the level of expertise you require in all of the areas you require it. And actually, you know, for the day-to-day roles we have people performing, it's unlikely somebody would need all of that because they wouldn't be able to work on everything at once, even if they did. So for us, it's very much been about fostering collaboration within our team, about helping our team members to upskill each other once they're hired. And, you know, that really involves hiring people who have both the curiosity and an appetite to learn about new areas, and also the capability to communicate their own area in a way where they can cut out the noise, as it were, and you know, communicate what's essential for this other person to understand in order to work together effectively. So that's kind of our priority. We also run, you know, drop-in sessions where we get into a lot more detail than people might need in areas other than their own, but that's more to satisfy people's professional curiosity than it is actually essential for the work.
Thank you very much. During the discussion after the talk of Araceli, she mentioned that we do have now already specialists with master degrees in quantum technologies and quantum mechanics and quantum technologies, but they're not being hired because they don't have specialized PhD knowledge. Are there certain programs now running or certain solutions where, for example, you can hire a master and offer a PhD program as in a collaboration, for example, with universities or research institutions? Is there a possible solution?
I can jump in. I have seen these, and I think exactly that's probably the only option. So what I have seen is more and more collaboration, and there are some masters that within the master, they include this collaboration with industry already. So I think it's both industry, they need to be open in collaboration with academia, and academia, they need to be open in collaboration with industry. So far, it has been so fundamental, and those researchers, they have been doing something that it was not applied until some years ago. So they also needed to change the mindset in order to say, oh, what I'm doing maybe can be applied to industry. And I have seen that in the last 5 years or so, a lot of people that they were really not interested in application of what they were doing in science, now they say, yeah, actually, I would like to work with industry. I would like to apply what I'm doing. So I think it's the fact that we are growing at the same time that we are creating the ecosystem. That's why the bottleneck is existing, but it's the only way. So we are hiring people, we are training people at the same time that we are creating the technology. As Horst mentioned, it's very cool, but as well is the solution. The problem to the solution is that we need to wait until the market matures a little bit.
Yeah, so we do have different dimensions. We have a near-term, middle-term, and long-term dimension. And on one hand, we do need bachelor and master degrees programs and PhD programs now, so that we have a new generation of specialists, let's say in 5, 6, 7 years. But we also, on the other hand, we do need a solution to train and educate employees at various organizational levels today. And Oliver, my question is to you. Do you have an overview of the current situation of available offers that targeting or addressing both of these dimensions?
Well, yeah, maybe Araceli has a better overview, but I'll try to answer that question. Yeah, actually, I think most of the activities currently done are in master programs, PhD degrees, stuff like that, though there's still plenty of room, I think, and a need for quantum industry-focused master's programs. So, as has been mentioned, where we really incorporate a collaboration and a cooperation between the academia and the industry side. I think there are also still some gaps if we think about undergraduate courses, which could be also specialized in quantum computing or quantum technology. Since I think there's a wide spectrum of roles. Of course, there are the specialists of everything, which we need. But there are a couple of roles, or lots of roles, where the quantum skills are, I would say, moderate, probably, especially in the engineering field, if you think about hardware and on the operational side. There, for example, undergraduate courses would be fine. And of course, as has already been mentioned as well, retraining and upskilling offers in a, let's say, coherent and consistent way, meaning that we agree in consortia together with industry, of course, and most important, industry, on the content, on the course structure, learning goals, that we have a coherent and qualitative education system, retraining and further education system. Because I think what would be worst when we have, I don't know, 1 million of offers and everybody is offering something, and somebody who wants to engage with quantum computing and quantum technology just has this jungle of offers and does not really know where to start. So we should really aim at certification, and I think the current opportunities and chances are that we are really collaborating in big consortia and can still agree on what we really fix in these programs.
Thank you very much. And you touched this important subject of certification. So how do we, so as I understand, currently there's a problem, so you cannot really assess or compare all the available courses, resources, and master programs. How shall we maybe start approaching this issue? Where shall we start with this?
I can give you what I know, what is already ongoing. Just to start with what I know, what we are doing in our platform, we provide CPD certification. This is continuous professional certification. This means that anyone who is in industry and would like to have training as part of their training development, the development inside their business sector, they can take those courses and get these credits. So they are globally available, and the certification is global, so everybody can use it. That's for industry. Now, how do we create something that is not out there? How do we standardize? This is another thing, and this is very hard. So what we are doing now at European level is trying to understand first the needs and trying to create something for those needs. That's why we have QT Edu on one side, we have QUIC on another side, and I think all other people here in the panel, we actually work together in developing all these in one way or another. So there are now ongoing strategies, consortiums, and ideas on how to build something that is going to be, at least at European level, strategically available for everyone, a certification that is going to be global for everyone in that case. So we are starting, and I think that's the only way, trying to work together and understanding the needs and assessing the market and thinking about the strategy together. Thanks.
Thank you very much. We discussed, I think Horst mentioned in his presentation already what kind of professionals from their perspective, professionals and skills would be needed in the near, middle and long term. Sebastian, how is it from your perspective? What are the most needed professionals and skills?
Yeah, I mean, it depends on how you define middle and long term. I mean, in the very long term, I think there is a bifurcation in this market. There's the skills and the people and the resources are required to actually develop the hardware and the software that compose quantum computing, and then there's the skills that are required to use quantum computing. And I think that the bar will lower on the user side over time, as we've seen with other sophisticated emerging technologies like data science. And AI ML. There were very, very high bar for skills that are required for being involved in the foundations of this cycle of AI and ML. There's, data scientist became a job description somewhere maybe 10 years ago. And now, your general enterprise developer has tools to use AI and ML in their day-to-day job. And there will be that sort of arc of development for quantum computing as well, but that's a very long term. In the middle term, I think, the focus on bringing together all these disparate fields and starting to define what is the field of quantum computing. There's some in the United States. There's some early degree programs. Harvard has a PhD now in quantum computing. UCLA is defining a master's level quantum engineering program. So I think, and I know there's similar activities in Europe. I think there are early stage, higher education programs that are starting to be defined. I think that's vital. And also just generally, regardless of what time horizon, just more of an emphasis towards trying to develop a quantum intuition as early as possible. And, the NSF, for example, has a Q12 education initiative that's run out of University of Chicago and University of Illinois in Urbana-Champaign. And that's an attempt to sort of bring together materials from academia, from industry, to help try to develop that quantum intuition as early as possible. So World Quantum Day, for example, in April, there were games, there were educational activities, there were talks, there were all sorts of other content that was generated just to try to bring that kind of way of thinking into the general consciousness and sort of the general STEM educational background. I think that the importance of that cannot be overemphasized, because it is such a different way to approach problems, whether you are developing the actual technology of quantum computing or you're looking at applications, as Dr. Weiss is pointing out, on the algorithm side or implementation of those algorithms. That all takes a very different way of looking at problems than we're used to in sort of classical IT.
Thank you. Samantha, you are now directly working on the side of the technology supplier, let's say, so you're trying to build a quantum computer with your team. What are the skills you are looking for?
Yeah, and that's a really interesting one. I think, what Sebastian says about developing quantum intuition is so fundamental. Because when we look at the skills that we're looking for, harking back to what I said earlier, we don't actually want somebody often who has this whole rounded expertise of everything quantum that they've touched a little bit of. And if you look at some of the degree programs that are being developed now, I think the University of New South Wales published a paper recently on what a kind of degree would look like. And it touches everything. It's, you'll learn some mathematics and coding, physics, engineering, including electrical circuits, digital and analog design. Now that will be very helpful, and there will be a talent workforce that come through it, but we also need the pre-existing talent workforce we're currently hiring in, which is just a digital analog IC design specialist who did a PhD in that, has decades of experience in it, or has come through that and specialized. But what would be helpful if they have that quantum intuition, that doesn't require them necessarily to have a degree program focused on it. Mm-hmm. And I think a lot of developing the future workforce for me, the way I see it, is engaging young people now to see the different pathways to a career in quantum. So not necessarily trying to overload them with a program that deals with everything, but showing them the different pathways, if they're attracted to a career in quantum, they could take to become an expert in an area we need. Because, certainly the classical hardware engineering has been, a huge talent stream for us that we need to fill. And as we've identified, there's a huge shortage in it already. I think there's a place for both degree programs and both approaches, but certainly by far and away the most important, I think, is quantum intuition, and exactly as you said.
How can we train or promote this quantum intuition? Do you have an idea?
Yeah, I think it's about, communicating things correctly in a way that's engaging and showing, young people in particular as they come through, or anybody looking to make a switch in their career, how the skills they have can apply to quantum and how they can make an impact. Exactly as Sebastian said, World Quantum Day is a great example. I know at Universal Quantum we've made proactive outreach projects in the past where we've gone out to the public and kind of demonstrated mini experiments or, put on, fun shows and tried to just engage people and get them talking about it. I think one of the biggest problems is people often hear quantum physics and just become terrified, and it's engaging them in that and showing them there's not anything to be too afraid of there.
Thank you very much. I would now like to switch to the subject of educational programs and ask you, Oliver, a question. What is your methodology and how do you approach development of education programs at University of Braunschweig?
Well, maybe I should first stress that we are focusing on general quantum technologies and mostly on the hardware side, so like quantum hardware engineering. But anyway, so our goals there are to offer an efficient and easy to access training and upskilling offered to industry partners, which keeps up to date and state of the art and constantly meets the industry needs and is on high quality level. That is to support by tech transfer, and we want to map coherently map all the diverse fields of QT and also integrate existing offers for further education. And that we plan to do by compact and short programs on short and medium time scale, tailored for industry especially. And the collaboration with the Technical University of Braunschweig and Rainer Müller, who's driving, or one of the driving forces in the European QT flagship education part, I should add, that builds a good basis. For example, they developed the competence framework, which already lists up lots of the competences needed, qualification profiles, learning goals are in development and stuff like that. So this gives a good basis for structured development, and also maybe something which is comparable. And also there in European-wide requirements assessment was carried out, and there we also take into account other assessment from the Quantum Economic Development Consortium from, I think that was the quick paper we have already seen. And the national network we are focusing on takes into account lots of strong players, both in research and industry. and reality ends with these partner and team up to build up this kind of qualityful and coherent ecosystem of quantum training offers with a goal of certification. So I think there's no chance to do it alone. We have all to team up to do this together. The industry stakeholders and partners, we are so far consulting more or less directly in the existing networks we have. Of course, on the National Metrology Institute, we have lots of partners in the hardware sector, I would say, enabling technologies, quantum sensing, and all the quantum computing components and hardware stuff. But in future, of course, we want to incorporate more industrial partner, build up an advisory board, and institutionalize the exchange, also by sharing, for example, PhD students, offering or making internship possibilities transparent, joint thesis and stuff like that. And from the PTB side, what we offer is really hands-on courses on quantum tech infrastructure. We are just building up, and this will be finished next year, a couple of user facilities which are robust and easy to use, user-friendly in the several areas of quantum technology, so from quantum communication of quantum sensing to, for example, integrated superconducting circuits, ranging from characterization, measurement facilities, and also low volume production lines. That is, for example, startup companies or SMEs can come there and try to develop something products they can scale up. So that we offer infrastructure for them and also the expertise which is allocated at our institute. So we offer them training and also consulting services if you want, so they can just come to the lab space, they get an office, they can be there like 4 weeks to a couple of months and just use our infrastructure. And by this we hope to really to foster like an ecosystem from basic courses over hands-on activities really to how to bring QT products into the market.
Thank you for your insights. Do you think, so as I understand correctly, you do develop quantum technology, so course on quantum technology on the hardware side. Do you think that quantum technology should also at least partially be part of the general engineering education, so that those who didn't particularly decide to go for quantum technology still get some basics during other courses, let's say?
Definitely. So I think this touches the issue which has been discussed under quantum intuition or quantum awareness. Mm-hmm. I think it's really important to incorporate at least some amount of QT or quantum content, for example, into all computer science degrees, into engineering degrees, and stuff like that. That every like a STEM student, for example, at least got in touch at one point with quantum technologies and knows a little about it.
Thank you.
So yeah.
And when we speak when we think about advanced computing, we can draw on experience of high-performance computing, and I think there is a discussion that it's important to bring programming and software development skills for high-performance computing also in a, so to say, vertical degrees, like in chemistry, in biology, in logistics, so that it also becomes part of the programs. And do we need to? As I understood from discussion, it would be great if we also adopt this thinking to quantum computing. And do we see already any developments in these directions, Araceli? in some universities, European or in UK or worldwide.
You mean more focus on specific business sectors?
I mean that in university degrees that are not engineering or not directly engineering that we have,
multidisciplinary.
For example, software skills, yeah.
Mm-hmm. I don't think there is much going on, to be honest. It's starting, which is good, but I think there should be much more. I have been involved in several initiatives at UK level, Europe level, and globally, and I think it's in the midterm for everyone. Again, Sebastian mentioned what is actually midterm. We should do more multidisciplinary because there are people hiring engineers that they need quantum, as Samantha mentioned, but we don't have those people because engineering, they are not aware that they could work in quantum. And the same people that are coming from engineering, sometimes they think that with a little bit of quantum they are ready, but they are not ready. So again, is this kind of a middle ground where we need to start thinking about multidisciplinary courses or programs, and the only way is thinking about creating something that is called quantum engineering. Whoever is coming from the first 2 years of an undergrad in whatever engineering, and then having this kind of additional one, it's not going to be a master's. It's really a new program that is going to develop their skill set much deeper than just 1 year master. But so yeah, it's starting, but there's not so much, and it has to be done. It's the only way the electrical engineers, electronics engineers, mechanical engineers, and other engineers that are really required at the moment are ready to join the workforce.
Thank you. Sebastian, do you have something to add here?
Yeah, I mean, I think that's all absolutely spot on. I would just broaden the aperture even out to, I spoke to the MIT Sloan Business School Tech Club a few weeks back, for example, and in many of the sort of academic consortia, they're regional and national consortia like the NQCC in the UK or Quantum Delta in the Netherlands, there is at least an expressed desire to bring in disciplines even outside of STEM, so business schools and law schools and other aspects of, because I mean, really, if we're talking about this disruptive technology, there's a requirement to sort of understand the implications and try to make the most of the opportunity and avoid the potential pitfalls from this powerful technology that are inevitable, that goes across the board, that is truly cross-disciplinary. And I think, I really think that in many ways, the challenge that we face right now from an education and awareness perspective is pervasive throughout the field, because you can think of the challenge of quantum computing as in some ways a co-design challenge, right? I mean, even within physics, you have decades of theory that is now being applied into experiment and then engineering and development of product. And that's a challenge in and of itself, just spanning those layers from theory to experiment to application. And that you see that same sort of co-design and communication challenge across every axis that you can possibly imagine in quantum computing. The whole thing is a communication and understanding challenge in many ways.
And one point I would like to add is also the following. At the moment, we see that rookies from the quantum arena come up and explore certain new algorithms on their side. And obviously, they are not aware about the status in, say, traditional high-performance supercomputing and algorithms over there. So, and this is given the immature situation that we have right now. We are in a really early stage, yeah. Also for the change aspect, very, very difficult. So at the same time, there are prospects that might pay off in the future, but given the present situation, it would be desirable to have an environment created also for the people to learn in the future, where they are also aware about the non-quantum approaches to the field, in particular in optimization. I mean, when you start trying to do some advertising and get a buy-in for a certain solution over there, you will probably get a hard pushback because there are a couple of solutions already around, and people from this arena, the young ones, are not even aware that this type of science is existing. So, but I think this is usual when you a usual change problem when you try to bring something in, yeah, but not a simple situation.
Thank you. I would like to move to next question, and that regards to the access for use and training users and access via cloud to available systems. Horst, are there any specific aspects that have to be considered from the perspective of the user company for this training?
I can only from our experience also recommend to do also this training with an experienced partner. I mean, you can burn a lot of money trying some things on platforms, but very likely it will be disappointing. So make it concrete. Have a certain problem, a toy problem, and there the problem starts. You need a person who knows what's possible, what not, how the effort is, how it is not, how it can be implemented, and so on. So I think that you need, even for this training stuff, you need some real guidance for this. It is, I think, of no use to simply go there and try out something or and so on. Yeah, that would be my recommendation. Have a teacher, have an educational person with you when you try to learn this, and it also needs commitment, long-term commitment. You won't learn it just by first try. It will take some time, and you also need a dedicated task in order to do this, and so on. So, in my opinion, it's sort of a project. It might be that you get access to libraries with use cases. That many initiatives are like this. Many startups offer this. I think that's a good point, really, to get a first-hand experience. I think it's better than trying to do it on your own. Afterwards, when you have some experience, it might be good then you need the hands-on experience. But I think it's a multi-stage process. At least my opinion. But technology is really difficult.
Thank you. Sebastian, how is it from your perspective? Because you work with...
No, I would definitely agree with and amplify what Dr. Weiss was saying. I mean, I think that is, in a nutshell, that's the right approach for an enterprise. It's almost at an institutional level the equivalent of building up quantum intuition, right? So problem identification, problem formulation, and a POC of some kind, even though the proof of concept, the pilot is not going to be providing any kind of advantage over a classical approach. It still is worth going through the entire process because there's enormous institutional learning that occurs from that. And I think, we have a number of ISVs who are building their software solutions on top of Bracket, on top of AWS. And I think that in particular, because it's very, very difficult to be an early stage software startup in the quantum computing field today. It's, as I said, there's no real advantage over anything you can do classically. So it's very speculative and very early stage. And so ISVs can be a really good partner for a large enterprise to do that sort of a guided tour through that problem identification and formulation and POC process that Dr. Weiss was describing. Because they're eager to learn more about specific industry use cases and implementations, and are willing. They are collecting by default. They're collecting the expertise in order to make that software startup work. So they're good partners for large enterprise, I think.
Thank you. I don't have so much time left, so I would like to wrap up our discussion and just ask you for a short statement. Let's say in the next 5 years, what is the main focus group we need to target with education and main competence that we need to build up? In a short statement. Oliver, would you like to start? Maybe.
Well, maybe from our perspective, that's focus groups, quantum engineers. What has been discussed, and we always get a feedback on from all industry partners, is that we try to clarify where is the real quantum advantage. So where does all the quantum technology overcome classical technology? For example, with regard to computing, as Horst Weiss has said, where is do we really have an advantage of quantum computing against classical HPC, for example?
Thank you. Who'd like to continue?
Okay, I give it a go. So for the next 5 years, we are talking about people that probably are gonna start at the university. So let's think about engineers, and as we mentioned before, any kind of engineer, chemist, mathematics, any kind of multidisciplinary kind of a field that we think that is just adding a little bit of quantum can be ready to join the quantum industry and spend their training in the current workforce in industry. So big companies and corporations and SMEs that are kind of starting this awareness or intuition phase in quantum, what do they need to be quantum ready in the next 5 years? I think those are the biggest focus.
Thank you.
Yeah, I'll jump in. I think to add to what's already been stated, which I agree with, I think there's also, this is a new field and we have an opportunity to be more inclusive and have more access, more distributed access to underrepresented groups in STEM. STEM does not have a great history of representation. And I think if we start now at the high school or early undergraduate level, introducing these concepts, building this intuition, and showing what the possibility is, right? I mean, if you talk to a PhD student in a quantum-related field today, they will tell you that they did not expect to have their skills be this much in demand, right? You know, I think it's important to show the possibility, that the path that exists now into this new emerging field, and the opportunities that exist, and also that other groups that are underrepresented in STEM today get the opportunity to be exposed to those ideas and start this field off on a more fair and just and egalitarian kind of stance.
Thank you very much for this point. Horst, would you like to continue?
I would like to add a point. I mean, we were at the moment very much in the hype state in quantum technologies. I assume that in the next year, very likely there will be a drop. I won't talk about quantum winter or so, but there might be a drop. In my opinion, we should be committed also from the society that this is a long-term effort. And I hope that this type of education that we just started in the hype models will survive, and that we still think that developing more quantum into the education is important also for the future, independently of what will come in the field, how the realization would be. If it's a psi-quantum million qubit system in the next 7 years or so, I don't know. But this unique combination that you need, that you understand a bit of quantum and its prospect for the education of engineers, software developers, data scientists. I hope simply that this is also, that we have there a commitment also from the government, because otherwise I have the concern that in 10 years, when there are breakthroughs, then all of a sudden we will start this discussion again, that we then don't have a workforce. Now it's time to be committed to the workforce development, and we should now try everything in order to project what it takes to make quantum operational for the industry in the future, independent of the technical oscillations that we will see.
Thank you very much. Samantha, do you have something to add?
I just couldn't agree more with the statements that have come before me. Particularly in increasing access to STEM subjects and increasing appetite for that as well, and bringing it and the level of engagement in it more broadly, and making that very specifically quantum focused as well. There are some efforts that have been going into STEM engagement in the last couple of years, and to really up the ante on making that quantum specific. And finally, I'd just add, in terms of quantum engineers, and in particular experimental physicists, trying to make it more accessible and easily for people to get experimental experience earlier on would be a huge help.
Thank you very much. Thanks again, all of you, for this interesting and insightful discussion. I wrote down several points to take away for the further work.